Germany never expected the Americans' sharpest blade to be invisible on a cold morning north of Kasserine Pass. 20th of February, 1943. 5 Sherman crews watched the dust hang and listened for a click. Not a bugle, not a flag, a click. Red 1, move, 2, cover left. The formation flexed across broken wadis with no line of sight. To the Germans, it looked rehearsed. To us, it felt simple. We could actually hear each other. What the report could not freeze on paper was the soundscape. Engines at 2,000 RPM, tracks biting stone. Then a clean voice through the headset, free of static. That clarity was not luck. It was frequency modulation FM sitting behind my right shoulder in a metal box we'd bolted down in Detroit. Records showed the U.S. standardized 3-tank radio sets on 22 July 1941, SCR-508, SCR-528, and SCR-538. Each set turned a medium tank from a lone brawler into a node that could think with others. The hardware mattered. The transmitter BC-604 pushed about 25 watts. That was roughly twice the punch of the German FUG-5 set common in Panzer V's. Our net lived between 20.0 and 27.9 megahertz, with 10 crystal set channels, no hunting a dial while shells landed. Commanders often ran dual BC-603 receivers, one ear on platoon traffic, one ear on company. The package weighed in at around 181 pounds, and it earned its keep. YFM because the battlefield is noisy. Amplitude modulation, the German standard, rides the size of a wave. So every spark plug, every generator brush, every lightning crackle of a track becomes a shout in your ear. FM encodes the message in the wiggle of the wave, not its size. Engine roar drops away, orders cut through, even under artillery. We could pass a fire mission without shouting. There were people behind the metal. Daniel E. Noble sketched the concept of FM for vehicles. Henrik Magnuski led the RF engineering that made it survive heat, dust, and vibration inside a tank. Their employer was the Galvin Manufacturing Company, renamed Motorola, an American firm that learned to build car radios and then retooled to build combat ones. Most historians note that German doctrine prized radios early. The difference by 1942-43 was density, suppression of electrical noise, and stability under motion. None of this made a Sherman invincible. Armor and guns still decided duels, but communication changed tempo. Tanks that talk turn minutes into seconds. They pivot, warn, and hand off targets. That morning near Kasserine, we did not outgun anyone. We simply arrived together. Figures reflect typical settings. Range and audio quality vary with terrain, antenna tuning, and vehicle motion. German sets performed better when stationary and well-grounded, but motion and interference often cut reach drastically in field practice. Sources selected U.S. Signal Corps technical manuals for SCR-508, 528. Motorola Company histories, Honeycutt, Sherman, Zaloga, Osprey, U.S. Army ETO after-action summaries, where sources differ. This episode follows majority interpretations. Nobody in Algiers expected the first American advantage to ride ashore inside a radio rack. On 8th November 1942, during Operation Torch, 2nd Armored's Shermans rolled off LST ramps near Safi and Fadala with SCR-508 sets humming on preset crystals. Net checks snapped across the beachhead short. Clean. Disciplined. The armor was new to theater. The network sounded seasoned. Across the line. The Africa Corps fought with experience, but under constraints. A typical 5-tank German platoon might field one, sometimes two, full transceivers FUG-5 sets able to transmit and receive. The other vehicles carried FUG-2 receivers only. Orders could go down. Few reports came back up. That pattern bred a rigid habit, the platoon leader talked. Subordinates answered with movement, not words. Knock out the command tank, usually the one with extra antenna hardware, and the net went quiet. Records suggest this weakness mattered more, as Allied radios became universal at the vehicle level. Kasserine Pass, 14-24. February 1943 made the contrast obvious. Tactically, the Germans carried the ground in several sectors, operationally. Another story crept over the air. First armored elements split by wadis, dust, and confusion kept passing bearings. Danger calls, and artillery requests over FM. Crews who had never shaken hands still managed to coordinate. German signals intelligence listening posts noted it. Too, the American traffic was unusually clear and consistent at ranges where their own sets yielded mostly noise. Reports from the 10th Panzer Division's intelligence section pointed to a troubling pattern every tank appears able to transmit. Not just leaders. The physics behind the impression were simple. German tank nets in North Africa largely relied on amplitude-modulated sets in the 27 to 33 memoirs band. The common FUG-5 transmitter rated about 10 watts in training conditions. That could reach a few kilometers. In motion, reality intruded ignition pulses, dynamo brushes, track noise, and imperfect suppression bled straight into AM. Range and intelligibility fell sometimes to a few hundred meters. FM, on the American side, same neighborhood of frequencies. Different way of riding the wave shed much of that interference. It did not make Shermans harder to hit. It did help them arrive together, call help faster, and hand off targets without guesswork. Sources selected U.S. Signal Corps manuals for SCR-508.528, U.S. Army After Action Reports, 2 Corps. Tunisia, Feb. 1943, Motorola. Corporate histories, Galvin Manufacturing, Honeycutt, Sherman, Zaloga, Osprey, where figures vary by source. Ranges and wattage are shown as typical, with performance dependent on terrain, antennas, and vehicle motion. Italy, September 1943, mountains that should have killed our radios gave FM its stage. In narrow valleys, the signal bounced, split, and came back dirty. AM sets on German tanks turned that echo into mush. Our SCR-508s rode the frequency, not the volume, so multipath faded and the words stayed sharp. No flags on ridgelines, no hand signals across ravines, just short calls blew too. Crest now. Platoons cut by spurs and folds still hit the same target line within seconds. Near Cassino, where sight lines vanished. American tanks kept cohesion while German nets went to static. First Armored's after-action notes read almost routine contact maintained across divides the enemy treated as walls. Orders passed clean, where AM delivered only noise. Boy Normandy. 6th of June 1944. Our Shermans clattered off LCTs with radios already hot. The SCR-508 nets tied tanks to shore fire control and, at times, to naval guns offshore coordination the Germans couldn't match. Then the bocage bit back. Hedges killed sight lines and swallowed sound. A new problem surfaced: we could talk to tanks, not to the riflemen walking 5 yards away. Their SCR-300 sets lived higher in the dial, about 40 to 48 milliards, while our nets ran 20 to 27.9 milliards. Different bands, different worlds. The gap cost time and, too often, vehicles. German infantry with anti-tank weapons could close inside the green tunnels, while nearby GIs struggled to warn us. The fix was brutally simple and very American. Crews bolted an EE-8 field telephone in a steel box on the hull and wired it into the intercom. By late July, as Cobra opened, a grunt could slap the handset and speak to the commander directly. Tank infantry cooperation changed overnight. Late July 1944, Operation Cobra cracked the bocage. From 25 to 30 July, 2nd Armored under Major General Edward H. Brooks used its radio net like a conductor's baton, moving more than 200 Shermans in overlapping thrusts. Contact reports jumped platoon to company in seconds. A threat, spotted miles away, became everyone's problem and everyone's shot. Fire missions routed through tank radios landed within minutes of target call. The effect on German defenders from Panzerlehr felt uncanny. American units seemed to pivot with shared sight. The contrast was structural. Panzerlehr, once an elite formation, fought in communication poverty. Many tanks either lacked transceivers or carried receivers only. Falling back on flags and hand signals in terrain where visibility seldom topped 100 meters. Sets that did work fought interference and short range. Coordination frayed. Local successes couldn't knit into a defense. Germany never expected to be outcommunicated in the very craft it helped invent. 2 decades before, American Shermans hummed onto European roads. German armor thinkers had already drawn the blueprint tanks must talk. Heinz Guderian, often cited as a chief architect of fast. Coordinated armor pressed for radios in every fighting vehicle through the interwar years. His pre-war writings stressed a simple idea: speed without communication is chaos. Yet by 1943, industry, logistics, and battlefield realities dragged that ideal back to earth. Production records suggest Germany turned out roughly 5,700 medium tanks that year, but fewer than 2,000 Fuji transceivers. Priorities and shortages pushed many sets toward command vehicles and assault guns. Platoons in line units often rolled with receivers only, or with nothing at all when spares ran dry. The paradox sharpened at the platoon level. German leaders were trained to command over the air, subordinates acknowledged by maneuver rather than chatter. On paper, it conserved bandwidth and fit a discipline-heavy doctrine. In practice, if the commander's tank took a hit, the net could collapse. Antenna farms marked leaders as lucrative targets. When that hub went silent, maneuver devolved into line-of-sight guesses, especially painful in broken terrain or under smoke. Soviet armor entered the war with an even thinner communications margin. The T-34, a rugged design mass-produced in the hundreds of thousands, frequently fought without a radio in 1941-42. Signals moved by flags, pre-planned routes, and close visual control methods that strained under rapid operations. Lend-Lease eased the gap by 1943 American sets, including variants of the SCR-508 family, reached Soviet command tanks. Even so, most historians estimate that by war's end, only about 1 in 4 Soviet tanks carried a working radio. The comparison did not mean Western radios were perfect. It meant they were present, interoperable, and densely fielded down to the vehicle. American industry made that density boring by making it routine. Motorola's Chicago Works, born as the Galvin Manufacturing Company building car radios, retooled into a precision shop for battlefield networks. An SCR-508 wasn't a box. It was a system. Roughly 2,748 parts had to meet tight tolerances and survive heat, dust, shock, and vibration. The BC-604 transmitter, the talker in the set, packed on the order of 474 capacitors and 385 resistors. Crystal oscillators held frequency when the tank lurched, when the compartment baked, when the commander shouted. Annual output climbed fast, about 300 to 800 sets in 1942, around 11,400 in 1943, near 24,000 in 1944, cumulatively. Wartime production topped 50,000 tank radio sets, enough to put modern FM capability into virtually every one of the approximately 49 324 Shermans built. That ubiquity was the real advantage. Technically, The American edge was not magic. It was reliability under motion. FM shed ignition spikes and generator buzz that rode straight into AM sets. Crystal control meant net channels were preset and stayed put. Dual receivers let a commander monitor platoon traffic while keeping one ear on company control awareness without sacrificing orders. The BC-606 intercom folded the crew into the loop loader, sees a glint right. 2 o'clock, the commander hears it at once. Throat mics and noise-reducing headsets made speech intelligible at combat RPM. Power came in 12 or 24 volts, with a dynamotor supply that filtered spikes. German sets often drew straight from the vehicle, and every spark could become static. Doctrine followed the hardware. U.S. armored divisions built combat commands ad hoc, task-organized groups that mixed tanks, infantry, engineers, and artillery for specific missions. Whoa! That flexibility only works if everyone can talk. With compatible FM networks across units, commanders could spin up a battle group before lunch and redirect it by afternoon without laying wire. To opponents trained to expect fixed groupings and radio-thin formations. The effect felt like sleight of hand. Arracourt. September 1944 made that effect measurable. 4th Armored Division faced German Panzer Brigades fielding Panthers with superior frontal armor and long-barreled guns. On paper, the matchup favored the Germans in a straight duel. The fight that unfolded was not straight. Every Sherman could report a contact the moment it appeared. Tank destroyers hunted by bearing and range fed over the net. Artillery observers in command tanks pulled steel onto map squares within minutes. Over roughly 3 weeks, U.S. reports credit 4th Armored with destroying about 281 German armored vehicles while losing 41 Shermans, a headline ratio that scholars still debate, but that clearly signals a command and control advantage. Terrain, weather, and training helped, so did the network. German intelligence noticed the symptoms but misread the cause, captured assessments from September 1944, praised American radio discipline and rigid procedures, attributing cohesion to training alone. That was only half the story. Procedure matters, but procedure fails when distance, motion, and noise erase words. Technology extended procedure beyond eyesight. German tactics, meanwhile, continued to hunt command tanks by antenna. Profile reasonable in their own net architecture. Ineffective against an enemy whose every tank could transmit. Relay and assume control. Ambush plans that banked on separating American elements often found those elements still aligned because line-of-sight separation did not sever FM contact. None of this should be read as single-factor determinism. Armor matchups, artillery density, air power, logistics, and leadership all shaped outcomes. But communications multiplied each of those factors. A mediocre plan executed coherently at speed can outrun a brilliant plan that cannot propagate. In 1943 to 45, the United States turned radios from a commander's accessory into the backbone of armored practice, Germany, which had once led the way conceptually. Could not match the industrial cadence to field enough stable sets, suppress enough electrical noise, or replace enough losses. The Soviet Union, fighting a different war with different constraints, prioritized mass and shock, accepting a thinner radio layer until late. The irony endures as a lesson rather than a taunt. The nation that wrote early chapters on armored communication lost the production race to build it at scale. The nation that arrived later made the network ordinary. On the battlefield, Ordinary beat exceptional, because ordinary meant every crew, every mile. Every hour had the same voice. Sources selected U.S. Signal Corps TM for SCR-508, 528. Motorola Galvin Corporate Histories. Honeycutt, Sherman, Zaloga. Osprey Series, U.S. Army After Action Reports, ETO. 1944. German Intelligence Summaries. 10. Panzer Div. 1944. Where figures vary. Ranges and production counts are presented as typical and may differ by theater, month, and unit condition. Nobody on the Rhine expected a single bridge to move an army in hours. March 1945, scouts from the U.S. 9th Armored Division reached Remagen and saw the Ludendorff Bridge still standing. A short call cracked across the net contact. Bridge intact, and within minutes 1st Army Headquarters had it. Within roughly an hour. Formations up and down the line were retasked to exploit the gap. No new wire to lay, no runners to dispatch. Radios carried intent faster than the current in the river. German defenders relied on landlines that fighter bombers had already shredded, where cables failed. Coordination slowed to a crawl. American tank platoons from different battalions flowed into the bridgehead and behaved like one unit overlapping sectors. Shared bearings, artillery on call, fire missions routed through tank radios, and forward observers arrived quickly enough to break up attacks while they formed. German counterblows came in fragments brave, determined, but seldom synchronized, and they were taken apart in detail. April brought the Ruhr encirclement, and with it the full consequence of a mobile network. 1st and 9th U.S. Armies closed a double envelopment using radio as the daily instrument of command. Columns pivoted on road nets. Boundary lines shifted. Fuel and ammo moved to whoever could keep pressure, inside the pocket. Hundreds of thousands of German troops, estimates cluster around 325,000, found themselves compressed as their own communications thinned to silence. Forward air controllers with radios marked targets for fighter bombers that hunted switchboards and headquarters. Records from the German side describe units losing touch with neighbors, then with higher headquarters, until local fights ran on habit rather than plan. Psychology followed the signal. American crews, even when hull down and alone on a crest, were never truly isolated. A headset click meant a platoon was still there, a battery still listening, a map still shared. German crews often felt the opposite when the wire went dead. A tank became an island. Otto Carius, a highly regarded German tank commander, wrote in his post-war memoir about the friction of battlefield communication, mostly in tactical terms, but the broader gap in radio density and reliability shadowed those accounts. The strategic thread from 1944 into 1945 is tempo. U.S. advances kept their rhythm because intent and information traveled as fast as fuel. Many German commanders underestimated that system advantage. They fought what they could see and hear, not the network behind it. Even Heinz Guderian, by late 1944, serving as Inspector General of Armored Troops, noted in internal correspondence that American coordination blunted German qualitative strengths in tanks. By the time Remagen fell, that assessment was on display in steel and static. Sources selected U.S. Army After Action Reports. 1st Army MAR, April 1945. Signal Corps Histories on Command Nets at Remagen. 9th Armored Division Unit Records. USAF Tactical Air Control Studies. Motorola Galvin Wartime Communications Histories. Carius. Tigers in the Mud. German Army Communications Summaries. 1945. Where accounts differ. Timings and strengths are given as typical and contingent on local conditions. When the shooting stopped, the counting began. U.S. and technical intelligence teams walked German vehicle parks with clipboards and signal meters, testing what veterans had felt over the air for years. Their verdict matched the field notes. German tanks often carried hard-hitting guns and stout armor, but their radios lagged, sometimes fatally. One U.S. Army Assessment Tech Intel report, number 176, judged German tank communications about 5 years behind American sets in practical performance. The gap was not one feature. It was a stack no-frequency modulation in combat nets, thin distribution of full transceivers, and weak electrical noise suppression inside vehicles. Signals that should have been orders turned into static. Soviet evaluators reached parallel conclusions, given access to captured German equipment. Red Army engineers studied both Axis and Western sets. Post-war doctrine and industry leaned toward American-style FM architectures rather than copying German AM patterns. That choice reflected a wartime lesson in a moving fight. Clarity under noise matters more than headline wattage on paper. The production math explains why that clarity showed up everywhere on Allied nets. U.S. factories built the SCR-508, 528, 538 family. In volume, figures commonly cited exceed 50,000 tank sets across the war. Sherman production ended around 49,324 vehicles, and American units aimed to equip virtually all with FM capability. Typical transmitter power for the BC-604 in a tank was about 25 watts. Crystal control kept channels from drifting. In practice, units reported voice ranges on the order of 7 miles 11 kilometers on the move, and 10 to 15 miles 16 to 24 kilometers under good. Stationary conditions always subject to terrain, antennas, and weather. German numbers looked different. Estimates suggest roughly 6,000 Fuji-5 transceivers produced against about 12,000 in medium and heavy tanks. Full transmit, receive capability at the platoon level often covered only leaders. Many line tanks carried receivers or nothing at all when losses and shortages bit. The common Fuji-5 rated around 10 watts, without FM and with limited suppression of ignition and generator noise. Effective ranges in motion could shrink to a few hundred meters. Stationary performance improved, but not enough to erase the structural disadvantage. Side-by-side timing studies echoed the airwave reality. American units could pass a fire mission and receive steel in 3 to 5 minutes under mature procedures. German requests, dependent on landlines or thinner radio nets, often took 15-30 minutes. These are typical figures. Sources vary by unit, terrain, and training. Principles emerged that outlived the Sherman. Modern main battle tanks carry digital radios, data links, and intercoms far more capable than mid-century gear. But the lineage is clear universal fit, stable channels, noise immunity, and shared situational awareness. The post-war Bundeswehr wrote that lesson into metal. Every Leopard model shipped with robust radios as standard, and German training literature emphasized that information dominance can offset platform disadvantages, a sober inversion of wartime experience. Late-century conflicts made the point in color footage. In 1991, coalition forces with dense, interoperable communications dismantled Iraqi formations that fielded individually strong Soviet-pattern tanks but radars and radios of uneven quality. In 2003, U.S. and Allied forces pushed the concept further with network-centric operations, fusing sensors, shooters, and logistics on digital nets. Historians debate definitions, but the functional thread runs back to the WW2 insight. A tank is not just a gun on tracks. It is a node. That node logic reframes the Sherman. Critics often call it adequate thin in armor, middling in gunpowder until late variants, fair. Yet, the SCR-508 turned adequacy into orchestration, 10 crystal set channels, dual receivers for commanders, intercoms that brought the whole crew into the loop. These features compounded. A loader could call a threat, a wingman could relay bearing and range, an artillery observer could turn a sighting into map coordinates, a company could pivot without laying a single inch of wire. The British phrase, "all arms," gains teeth when the arms can talk. German forces sensed the effect, but, as records suggest, misattributed the cause. Captured intelligence summaries in 1944 praised American radio discipline and standardized procedures true, but incomplete. Discipline fails without intelligible signal. Technology sustained the discipline across dust, motion, and shock. The fixation on command tanks made sense in a net where few vehicles could transmit. Against American formations where nearly every turret was a transmitter killing the visible antenna did not silence the platoon. Memory carries a quote from Wilhelm Keitel at Surrender, "We built better tanks. You made them work together." It is likely apocryphal. Still, the sentiment captures a real asymmetry. The United States did not just build 49 324 Shermans. It built roughly that many network nodes and made them boringly reliable. The Wehrmacht, for reasons that ranged from industry and materials to doctrine and attrition, could not do the same at scale. The Red Army, fighting a different war under extreme constraints, accepted thin radio density early, then layered in Western sets where it mattered most. None of this argues that radios alone won the war. Air power, artillery, logistics, training, leadership, and strategy mattered enormously. But radios multiplied those advantages and reduced friction at the point of contact. The electromagnetic spectrum became maneuver space if you can move intent faster than your opponent can perceive it. Your force behaves larger and quicker than it is. Veteran accounts underline the human side. American crews often describe the relief of a clean voice in the headset under fireproof. They were not alone. German crews, by contrast, frequently recount fighting as isolated teams when the wire went down or the platoon net thinned to silence. Otto Carius, writing after the war, dwells on tactical technique more than systems. But his stories of friction sit in the shadow of a communications gap widely documented in signals histories. The legacy is practical connection beats isolation is not a slogan. It is an engineering requirement. WW2 proved that requirement at scale in the decades since. The boxes changed from vacuum tubes to software, but the checklists look familiar. Suppress the noise, lock the channel, equip every vehicle, train to the net. When nations forget those basics, they rediscover them the hard way. Sources selected U.S. Army Technical Intelligence Report, number 1-76, U.S. Signal Corps Technical Manuals, SCR-508 per 528, Honeycutt, Sherman, Zaloga, Osprey Series, Motorola. Galvin Wartime Histories, U.S. Army and German Communications Summaries. 1944 to 1945, Carius, Tigers in the Mud, where sources disagree. Figures are given as typical ranges with performance contingent on terrain, antennas, maintenance, and unit procedures.